First example. You can also do the line section sometimes, alright? It says there's 2 times x. We're all in agreement that 2x times x. And then you add 4 and then the answer must be 10. Alright, so you can do that line section. I just want to show you, it won't always be easy to do a line section. Then it is useful to have a method that will always work. Alright, so we're going to look at yesterday's 2 methods again. For the first method, remember that is where we set up a flow diagram and then we work backwards from it. Okay. You can also eventually do it without setting up a flow diagram. I just think it's quite nice to have it in the examples. So what we need to do is we need to look at our variable, which is x in this case, right? That's what we're solving for. You need to ask yourself, when you're setting up your flow diagram, what is happening to x? Okay. So if we're looking at what's happening here, 2x plus 4. What is happening to x first, right? Because there's a times 2 and there's a plus 4. What do you think is happening first? Am I first multiplying x by 2 and then adding 4? Or am I first adding 4 and then multiplying that by 2? Okay? Multiplying. Alright? I'm first multiplying x by 2. And then that answer that I'm getting, which is 2x, I'm then adding 4. Okay, so let's set up our flow diagram. We're starting with x again. Remember the input value, the variable, that's always what you're starting with. We are then multiplying that by 2. Then we have a second step. We are then adding 4 to that answer. And then what is the output value? What is the answer that we're getting? 10. Now guys, when you are working backwards, you are not only going to do the opposite operations, because that's what we spoke about yesterday, right? What's the opposite of adding 4? Subtracting 4. And then what's the opposite of times by 2? Dividing by 2. So we are going to do the opposite operations, but guys, we're also going to do the opposite order of operations, right? If we're looking at this, remember we said first we're timesing by 2, and then we were adding 4. Now when we're working backwards, we're first going to subtract 4, and then we're going to divide by 2. Okay, so that's what we're going to do here. Our first step is going to be to minus 4. And then we are going to divide by 2. So not only are we reversing the operations, we're also reversing the order in which we do those operations. Okay, that's how we work it. So guys, I often say to my grade 8 classes that basically when we are solving an equation, because we're working backwards, we are applying BODMAS backwards, right? Do we remember BODMAS? Brackets, then R, then division, then multiplication, then addition, then subtraction. When we're solving an equation, we're actually working backwards. We're going to do the addition and the subtraction first, and then we're going to times or divide. Okay, so you can also just write that at the bottom there, if that helps. BODMAS backwards. Okay, so first we are going to minus 4 from the other side, right? That's the opposite of the plus 4. So what's going to be left, guys? If this plus 4 is not there anymore, what is left on the left-hand side? Just x. 2x, right? If I'm just, we can almost kind of say removing that plus 4, we're going to minus 4, you're still going to be left with 2x. Okay, so we're going to say 2x is equal to 10, which is the number that was there, and now the opposite of adding 4 is subtracting 4. Okay, that's that step that we're doing. We're doing the first backward jump on the flow diagram. What is 10 minus 4? 6. So 2x is actually equal to 6. You can't write x equals 6, guys. X is not 6. Okay, you have to take 2. Now, what's the next jump? What am I doing? What's the opposite of multiplying by 2? I am Dividing by 2. So now we're going to say, okay, when you divide by that 2, we're just going to be left with x. This is going to be 6 divided by 2. You can write it as 6 over 2 if you want to. So what is my x value? What's 6 divided by 2? 3. Let's go back. Let's check if that is actually true, guys. 2 times x. So 2 times 3 is what? 6 plus 4. Does that give me 10? Yes. Okay, so we have the right answer. Okay, it's obviously a bit more difficult when we have multiple steps, guys. So we are going to do a few examples. That was the first method, right? When you do your flow diagram, you work backwards. The second method was where we are trying to get rid of everything that is around the x. Okay, so we're quickly going to look at how we would do that. Now, guys, this is where the BODMAS backwards thing comes in handy. Now you need to ask yourself, BODMAS is normally we times first and then we add, right? But now we're doing it backwards. So now the addition, we're going to have to get rid of first and then the time. Okay, so how do I get rid of a plus 4? How do I cancel it out? What must I do? Subtract. Okay, so we are going to minus 4. So we have our plus 4 minus 4. Right? We do that so that the plus 4 is cancelled out. Because 4 minus 4 is 0. But now we have to do the same thing on the other side. Okay, so we are left with 2x is equal to, because now 4 minus 4 is just 0. Okay, so we're cancelling out that. So we're left with 2x is equal to 10 minus 4 is 6. You guys see that that is what we did in the other method anyway. Okay, our thinking was just a little bit different. Now we need to ask yourself the other thing that's around the x that we need to get rid of is the times 2. How am I going to get rid of the times 2? By dividing by 2. Okay, so now you're going to say 2x divided by 2 is equal to 6. And now I have to also divide that by 2. Whatever you do on the one side of an equation, you have to do on the other side. Okay, what is 2x divided by 2? X. And what is 6 divided by 2? 3. That helps you can. Okay, is that fine, guys, for that first one? All right, let's look at another one. For example, 2. 2p minus 34 is equal to 0. Okay, so now we need to solve for p, right? That is the variable that we have here. So let's quickly set up our tree. Oh, why do I keep saying tree diagram? Sorry, because I'm doing that with my team. We need to set up our flow diagram. Right, so p is the variable, so that's the input value. Now, guys, if we're looking at this equation that we have here, what am I doing to p first? Am I first multiplying it by 2, or am I first minusing 34 from p? First multiplying by 2, hey? So 2 times p, and then you minus 34. All right, so the first operation on this side is times 2. And then the second operation is subtracting 34. And what is my outcome value? Output value, rather. What's my answer? 0. Hey? Okay, so now we need to work backwards, guys. What is the opposite of minusing 34? Adding 34. We're going to do that first. Let's quickly do that, actually, before we even write the next one. We're going to add 34. So we're going to say 2p is equal to 0. That's what we have on that side, right? And now we are adding 34. What is 0 plus 34? That's 34. Okay, then if we look back at our flow diagram, what is the opposite of times it by 2? Dividing by 2. So now we're going to say P is equal to 34 divided by 2, which is what? 17. Again, we can check our answer. We can put that P, that's 17. What's 2 times 17? 34. Minus 34, that is 0. Okay, so P equal to 17 does make my equation true. Right, let's do the second method quickly. And guys, when you are doing these on your own, you're just going to do one method, okay? You don't have to write both. You just choose the one that you prefer. So I'm just going to write my equation down again. 2p minus 34 is equal to 0. We remember BODMAS backwards. When we're solving the equation, we are essentially working backwards all the time. So the order of operation is also, the order of operations is also going backwards. So am I going to do the times first or the minus? Get rid of the times or get rid of the minus? The minus first, okay, because that's there at the end. So what is the opposite, or sorry, how do I get rid of a minus 34? By adding 34. Okay, so we're going to say, we have our 2p, we have our minus 34. Now to get rid of that, I need to add 34. So guys, in a sense, you're also actually doing the opposite operation, right? Are you picking up on that? To get rid of the minus 34, you do the opposite operation, which is adding 34. Okay, here you then need to do the same thing on the other side. So you had a 0 there, you must now add 34 to it. So what's now left on this side? 2p and a 0, right? So just 2p. So that is equal to, on the other side, we have 0 plus 34, which is just 34. And now we need to get rid of that times 2. How do you get rid of the times 2? You divide by 2. Again, it's the opposite of times by 2. Right? So we're going to say 2p divided by 2 is equal to 34 divided by 2. You have to do the same thing on both sides. So this is p, right? 2p divided by 2 is p. And what's 34 divided by 2? 17. Okay, I'm going to make you guys do one on your own quickly, and then we're going to mark it together. So number 3. I did make a worksheet for you guys, but now I see that some of them are the same as one that we've done already. It's very silly. Yeah. Okay, let's do this one. 4x plus 1 is equal to 25. All right. That is number 3. I would like you guys to do that one on your own quickly. I'll give you 2 minutes. Now you can decide, do you want to do the flow diagram method or do you want to do the how do I get rid of this thing? You can, yeah, but yeah, see if you can practice one of those. No, you can just do that kind of thing. Okay, let's take a look. Alright, guys, what is the opposite of adding one? Subtracting one. So we're gonna have 4x is equal to 25, and then you subtract one. Sorry, let's take a negative now. What is 25 minus 1? 24. Now, guys, if you feel comfortable enough, you don't have to show this thing. Okay, you don't have to show that you're doing 25 minus 1. You can just do that in your head and get to 24. But this step you have to show. You will get a mark for this. Okay. Now, what is the opposite of, what am I doing to x over here now? Timesing by 4. What's the opposite of timesing by 4? Dividing by 4. So now we're going to say x is equal to 24 divided by 4, which is what? 6. Again, you don't have to show this calculation step. You guys are going to help you, please write it down. Right? There's nothing wrong with that. You are going to get a mark there for it. Okay, so 2 marks. If you do it by inspection, you'll get both marks for the answer, but if your answer is wrong, you will get it. Now guys, the thing with doing it by inspection, this is a 2-mark question, right? So say in this step, you made a mistake. Say instead of minusing 1, you added 1, right? And say you wrote 4x is equal to 26. Now that's wrong. Okay, because the opposite of adding 1 is subtracting 1. So you're supposed to minus 1 from 25. So there you will lose a mark. But now, if you go further and you now say, okay, x is then equal to 26 divided by 4, right? This is not a whole number, but we can write it as 26 over 4. And can I simplify that, guys? Is there a number that goes into 26 and 4? 2, hey? Not 4, unfortunately. 2 though. So you can divide the top by 2 and the bottom by 2. So what is this? What's 26 divided by 2? 13. And 4 divided by 2 is 2. But guys, even though this is wrong, you have worked correctly with your mistake. So you will get a CA mark there. Right? So the danger of doing something by inspection is if by inspection you made a mistake and you're just writing x equals, say, 13 over 2 with no working, you're going to get 0. Okay, but if you show working, you will only do the mark where you're actually making a mistake. If you then carry on correctly after that, we give you credit for that. Okay, so it's definitely much more, it's a much safer option to show all your working. Okay, guys, this was method 1. Basically thinking, what am I doing to x? And then doing the opposite on the other side. But you also could have used the second method, which is where you are showing 4x plus 1. If I want to get rid of that plus 1, I need to minus 1. And I must then do the same thing on the other side. Right? So you then get 4x is equal to 24, which is exactly the same as what we got here. That is again where you will get your first mark. And then the next step would be, okay, now in order to get rid of that 4, I need to divide by 4, so I must do the same on the other side. So x is again equal to 6, and that is again where we get the guys, are we noticing that we're actually doing the same thing in both methods? Right? In the second method, you're just writing a little bit more. Because in this method, you are showing, okay, I have a plus 1, so now I'm at minus 1. Right? On this side, you're not writing that because you're just asking yourself, what is the opposite of plus 1? Minus 1. Right? So I do that on the other side. Okay, so guys, writing this little extra bit is going to take 2 seconds. Okay, and if it helps with your thinking, then please write it down. Okay, yeah. Yes, just finish the little task. Okay, one more that you guys are going to do on your own, and then we'll mark it, and then I'm going to give you a worksheet to do. Actually, sorry, I want to do an example with you quickly. If you haven't done a type like you haven't done before. Right. Okay, let's look at that one. Sorry, I did say you're going to do it on your own, but I actually want to do this one with you quickly. And then we must also do one where the variable is in at the bottom of the fraction. Okay, we haven't done those yet, so I'll do one like that as well. Okay, so for this one, guys, what do we think happened to x first here? Did I first multiply x by 2 and then add 1? Or did I first add 1 to x and then multiply that by 2? I first added 1, hey, it's in brackets. This means that I'm saying whatever my x value is plus 1, I'm then multiplying that by 2. So if you wanted to draw your flow diagram for this, you would have an x. First, you are adding 1. And then you are taking that answer, right? X plus 1. And you are multiplying that by 2. And the answer that we are then getting is 10. So when we're working backwards now, we are first going to divide by 2. And then we are going to subtract 1. And guys, if we think quickly of BODMAS backwards, what is the B in BODMAS? What does that stand for? Brackets. So if I'm saying we must now do BODMAS backwards, we're supposed to do the brackets last, right? So this plus 1, the plus 1 that is in the brackets, that is what we're going to do last. Okay. The times 2 that's outside the brackets, we're going to do that first. All right, so what is the opposite of timesing by 2? We wrote it over here. Dividing by 2. So when I get rid of that 2, right? When I do the opposite of timesing by 2, I'm going to be left with that bracket, x plus 1. You can write it in a bracket if you want, but you can actually also leave that bracket or those brackets out. Because when that 2 isn't there anymore, there's no reason for there to be brackets. Okay, but you can leave it there if you want to. Now again, sorry, what did I say? The opposite of times by 2 is dividing by 2. So we need to do 10 divided by 2. Again, this step you don't have to show. You don't have to write out 10 divided by 2. You can do that in your head. So here we have x plus 1 equal to what is 10 divided by 2? 5. Again, if you wanted to leave your brackets in there, that's perfectly fine. Now, what is the opposite of adding 1? Subtracting 1. So I need to say 5 minus 1. Which is what? 4. Does that work? If my x value is 4, what do I have here? 2 times 4 plus 1. What's 4 plus 1? 5. And then if I times that by 2, do I get 10? Yes. Okay, it does work. The other method, I'll just do it here on the side. is where you think of how you can get rid of something. So now, guys, because we're doing BODMAS backwards, we need to get rid of the 2 before we get rid of what is inside the bracket. Okay, because BODMAS is brackets first, but BODMAS backwards is brackets last. Okay, so we first need to get rid of this 2. What am I doing with this 2? I'm timesing it by the bracket, right? So what do I do to get rid of the times 2? I have to divide by 2. Now for this one, I'm actually going to write it as a fraction. You can write it using the division symbol if you want, but I just think it's maybe a bit easier to see like this. Remember, a fraction also means division. You can write it using a fraction on the other side, or you can write 10 divided by 2 if you want. It's fine, it means the same thing. But guys, do we remember what happens to 2? They cancel out, hey? Because we forgot that all canceling out if you have a fraction. We haven't done it in a while, it's fine. So here I'm left with x plus 1 equal to, just like we had over here, 10 divided by 2 is 5. Now how do you get rid of a plus 1? You do a minus 1. So here, plus 1 minus 1 is 0, so I actually just have an x. And what is 5 minus 1? 3. Okay, I actually think I don't want to do the other type because I don't want to confuse you guys. I just want you guys to practice these types of equations first. So I'm going to hand out a worksheet now, and then I'm going to tell you to leave a few of them out, okay? Okay. Listen up, I'm telling you the ones that you need to do out for now. Does number 1 look familiar? Isn't that the one we just read? Isn't it? The first one? Oh, why did I think? No, sorry, never mind. It's all me. Okay, so do number 1. Leave out number 2 for now, please, guys. We will do number 2 together on Monday. Does number 3 look familiar? Yes, that was actually on the previous worksheet. Okay, so leave out number 3. What about 6? You've already done 6 as well, and leave out 6. 7, bit of an extension one, I'm going to leave 7 in. Okay, you kind of can do like a combination of the method and the inspection for number 7. So maybe make a star next to 7, just as a reminder. That is a bit tricky, that one. So if you're not able to do that, don't stress. You can certainly do 1/6 of number 7. Okay, you might not be able to get to the final answer. 8, you can also do. 8 looks different from what we've done before, but see if you can do that one. So maybe make a star next to 8 as well. Okay, 8 is also a bit complicated, but see if you can apply the method there. 17, also make a star next to 17. Then I think leave off 10 and 20. Also, just for now, we'll do those on Monday. Okay. I'll repeat it. Right, so the ones with stars are 7, 8, and 17. You are trying those, but they might be a little bit difficult. And then you are leaving out 2, 3, 6, 10, and 20. Okay. You can work on that now, guys. Let's see how much time it is. Okay, you have about 20 minutes, guys. You can definitely finish in that time. Okay, so keep going. Yeah. Yeah, if you don't finish this in class, you need to finish it at home.